Okay, this is about the Rydberg idea I wanted to share. We have come across the Rydberg constant, like okay, let me explain the basic. If you want, okay, you try. I'll give 2 minutes time. See, it is. I think let's have some general discussion. Then I'll get into the question. I'll bring the question later on. Okay, let me paste it below. Okay. It's a very important. In books, we don't have much discussion, but can be possibility of asking that one. So it's just based on the basic concept, nothing to do. Some reduced mass concept what we earlier we had no. So that has to be taken into the picture. I'll come to the question later on. First, let me discuss what do you mean by that Rydberg. Why is asking specifically Rydberg constant for hydrogen atom, then for other atoms? For different atoms, will it be different? Yes. So how it will be is what will begin like this here. Okay, let's do one thing. We have studied the hydrogen atom. It will be Z equal to minus C. So here, what is M? M is the mass of this, and M is mass of revolving electron, no? And it will be revolving. So then what is the expression for the hydrogen spectrum? 1 by lambda. This should be equal to in terms of Rydberg 1 by Ni square, Nf square minus Ni square. So how do that Rydberg and what is that R? So RH shall I write? This will be because very popular since we discussed for only hydrogen atom. Okay, it was we took it for granted R. Okay, that R only now it is Rydberg constant for hydrogen atom. So what is that RH here for that hydrogen atom? It should be Me e to power of 4 by 8 epsilon naught Ch cube. What is Me? Mass of electron. There it was only M. Let me write it Me. And what we have neglected, even in fact, what will happen? The mass of nucleus also should be considered. They'll revolve about the common center since the mass of electron very much greater than, since the mass of electron very much, revolving electron very much greater than that of the nucleus. So what we made a condition is, okay, let me take, this is the revolving electron. The mass of revolving electron is very much less than compared to mass of nucleus, no? So the formula, but if you consider even the mass, so I think the same formula will become like a reduced mass is what you have to bring. So this will become mu h e to power of 4, 8 epsilon naught C h cube. So what can be mu h? We can write it as me by m plus me. Okay, let me take m common. So this will be 1 plus me by m. This is mu and m. Little bit careful. Yeah. Let it be. So what is I indicated in the diagram? Mu h equal to, this will be me1 minus by binomial expansion. Okay, let's do remember. It is like this here. This is for reduced mass for hydrogen. What is mu h? So what was the question? Positron and electron. I'll come to the discussion later on. For deuterium, let me bring. So what is the deuterium? Deuterium atom, how it will be? Anybody? Shall I go for Z equal to 1? And for deuterium, what one proton, one neutron will be there, no? And one electron will be given. So this is a hydrogen atom. Okay, let's go for deuterium. D-U-T-R-I-U. Deuterium atom. So what is the deuterium atom? Z equal to 1. It will be 2m, no? One proton, one neutron will be there. 2m, and this is revolving electron. This is Me. Have like this. Okay, no. Similarly, what is the reduced mass for this? This should be mu d. Shall I directly adjust it? Me into 1 minus me by 2m. No need to come from again from the beginning. Okay, this RH is what? I kept it here, no. The reason for that, why the Rydberg constant will be different will S, the reason, this is the thing. So what is RD? You can write it now. RD is equal to mu d e to power of 4, 8. Okay, look at now the Rydberg constants, how lambda and R are related, inversely proportional. So therefore, and for any atomic structure, this NINF will be same, no? If I take the transition from the N equal to first excited state to ground state. So therefore, so what we can write, lambda H RH equal to lambda D by mu D. First, this one, no? Let me equate here, RH by mu H equal to RD by mu D. Okay, how lambda and Rydberg constants are related? Inversely proportional. So this, can we write, can we have one more? Okay, this one be lambda H RH should be equal to lambda mu by R mu. Okay, now the mu we know, so we can replace like this lambda D. We're all needed, no? Okay, this is, yeah, lambda D by lambda H equal to mu H by mu D. Some any numericals they may ask you, just I wanted to give this information. Okay, now if I know Rydberg constant of hydrogen atom, can I find out the Rydberg constant of deuterium atom? I can use this equation. So like this, for hydrogen, let me keep standard. For any other atom I want to know, I'll take help of hydrogen atom. In terms of that, I can express. So similarly, the wavelength, reduced mass concept, if you know, there's a relation. So therefore, what is the Rydberg constant for deuterium atom will be in terms of mu h by mu d. Mu h and mu d will be very difficult to calculate. Instead, what when lambda d and lambda h will be much easier. Oh, okay, this so, maybe sometimes they're asking this. So okay, that's why I just wrote it. Okay, this is something very important. So the Rydberg constant for deuterium atom will be in terms of hydrogen atom, it will be this much here. So in exam, they may ask you questions. So therefore, I just took the deuterium because it's like a hydrogen like atom only. Okay, but our question is what like? Okay, this one RD, write it. What is RD? I should write.
Sir, in the right side, that is lambda, sir, not R.
In this one,
Sir, the corner one, sir, right corner
here,
in the box.
this one,
Bottom, sir.
here.
Yes, sir. That.
No, I wrote it. Oh, we'll do one thing. I'll take it on this. This will be because I'm more interested on this one. If you want, okay, later on you divide it because again you'll get deviated from the concept. Okay, no.
He's telling it will be mu d by mu h, sir.
Yes,
D
sir.
is equal to RH mu d by mu h. Okay. This, yeah. Lambdas also, if you want, you can bring it. I'm not interested. So if you want, you can write that also. How lambda and RH will be, because for even deuterium atom also we can write like this. So even for deuterium atom, lambda deuterium is equal to lambda H, we write, should be equal to Rydberg constant of deuterium 1 by Ni square. Now they may test with questions like this. So therefore even for, they may say like what is actually thing is, in advanced exam, they may ask you to plot the spectrum of deuterium atom, like hydrogen spectrum how we have for deuterium atom. So tell me what is the difficulty for you? You should know Rydberg constant, that's all, no? How to get the Rydberg constant of deuterium? Okay, bring from here. Getting the idea? So these are interlinked problems. So in exams, we may expect situations of like this. So the now you can select a deuterium atom, sir, you are not explained, it's not there in textbook. Maybe the advanced professor wanted you to think like this. Please be alert, because there's now we are in revision stage. No, better to explore some higher level also. We can plot now deuterium spectrum also. The hydrogen spectrum is very important in terms of that we can express it. Even the wavelength also. If you know wavelength corresponding to first Balmer also for hydrogen spectrum, for other atoms, hydrogen like atoms with one